Oh, wow. Long uni, bro. Look at this thick packet. Alright. So, let me take all the art. Alright. So. Lewis dot symbols. I assume you know what that is. If you don't, that's like the valence electrons. The octet rule is obviously octet. The octet rule is basically all the elements have to have the 8 thing. Yeah. I bet. So the unshared electrons are called the lone pairs, and a single line represents 2 shared electrons in a Lewis dot structure. So starting off easy, F2, how many electrons are being shared? 2 electrons. And shared. So F, how many lone pairs? There are 1, 2, 3, 4, 5, 6 lone pairs. 6 lone pairs. So this is the Lewis dot structure, assuming you already know about all that. Oh my gosh. Alright. The 5 rules. Oh wait, no. 6. Oh, nah. And 1, 2, 3, 4, 5, 6. Okay, number 1, add valence electrons. V electrons. So for fluorine, that would be right here. Number 7, 7 electrons. So 14 total electrons right here. Number 2, most electronegative in the center, surrounded by others. Electronegative center. Alright, so number 3, covalent bond between center and outside. And then the electrons go to the outer, like the electrons in the electrons go to the outer. You get the idea. Or I wasn't even drawing it in camera, but the electrons go in the outer. Alright. Number 5, check for octet. 6 ties into 5. If not, create a double. Oh my gosh. Double / triple. Alright. They don't love you like I love you. Alright, so basically, if a formula is ionic, then it is soluble and has a strong or weak conductivity, and obviously molecular is not soluble, and it has no conductivity. Just to recap, ionic is metal and non-metal, and molecular is completely non-metals. That is already Lewis dot structures. They are easy, but I will just do it. So for CF4, F, C, 1, 2, 3, 4. So carbon has 4, fluorine has 7. 7 times 4 is 28. 28 plus 4 is 32. 32 minus 8, because the number of lines is 24. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 24. Yeah. Alright. So the center, it is important to know that the center can't be hydrogen or a group on group 7. And they can't have a double or triple bond. Okay. So electron geometry. And molecular geometry. Molecular geometry is basically the number of lines this is the amount of things attached to center. Okay, so for learning electron geometry, there is linear trigonal planar tetrahedral. And for molecular geometry, that is basically the same list plus 2 more lone pairs and trigonal pyramidal. So linear can only be linear for both. So electron geometry is linear and molecular is also linear. They can't be like lone pairs. So linear and linear for molecular geometry and electron geometry. Let's see. Okay. However, in a trigonal planar, there's it can be just a regular trigonal planar and a trigonal planar, which is just the center and plain old bonds. This one, there would most likely be a triple bond, or no, a double bond. Yeah. The other trigonal planar would be actually, what did I? That's my bad. It would be called bent. I was like, what? Alright, so bent. So this one would be center, 2 lone pairs, boom, boom. Because there are 3 things attached to the center atom, the lone pair, this bond, and this bond. So the tetrahedral and I'm not writing that. So 2, 3, 4. This is tetrahedral. Tetrahedral. Bent is when there's 2 lone pairs on each side and 2 bonds. Tetrahedral and trig pyramidal. Trig pyramidal only applies to tetrahedral. Just think about it as a pyramid. Just 1 actually, I'll retry it. Here, 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 here. Just, yeah. That's basically that for that. And my pencil like is actually tweaking now, so I have to sharpen it. So formal charge onto formal. So the formal charge is the valence electrons minus the number of like electrons on the outside, so the dots. There's the dots. Minus the lines. So in OH in OH minus 1 brackets minus 1. So you would do O has 6 valence electrons. Alright, I forgot to. You can barely see that, but it's fine. 6 minus 1. Hydrogen has 1. Minus 0 dots minus 1 equals 0 equals negative 1. And yes, you can see this matches with that. So yeah. So basically the only time you should not get 0 is there's no thing there. So electronegativity. We are given the list for electronegativity, and okay, so in case you forgot the electronegativity, let's do it for H2O. So OH as usual. Alright, so given the list right here, H has 2.1, O has 3.5, so let's write that down. It's 2.1, 2.1, and 3.5. So then the thing would turn into HO dot H. And then you're gonna add the dipole arrows, the arrow, then the line thing. It is pointing towards the most electronegative, because that's the one with the most, the strongest pull. So that's how you determine dipole arrows. Another example is CH2L, HHCO, double bond right here. This. Carbon has 2.5. Using the previous, it would go down here. Then these would go to the carbon. Alright. The 3 different types of bonds are covalent, polar covalent, and ionic, which is 1.8 plus 0.5 to 7, 0 to 0.4. So this would be actually, let's talk about polarity, because that's probably the most confusing, probably. So to find the polar shape, you basically just look at the the shape of the thingy majiggy. Yup, real descriptive. The shape of the Lewis structure. So, for example, CO2 and SO2. This one is non, this one is polar. Why? Because CO, 1, 2, 3, 4, 1, 2. Yeah. However, sulfur, 1, 2. Oh, boom, 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 boom. Dipole arrow, dipole arrow. As you can see, not the same, so it's polar. But what if it's like N2 or like H2O? So N2, so N is 5, so 10 total. So 2, 3, 4, 5, 6, 7, 8, 9, 10, boom. 4, 8. As you can see, the thing is equal because they cancel out. Think of it like a tug of rope. Like this is the middle, the amount of force. Yeah, I don't know what I'm trying to explain. Yeah. With the amount of force, they are equal, and if they are equal, then it is nonpolar. So that's for electronegativity. So, like, for like a real example, nitrogen, 3 each side, boom. Yeah, they cancel out. But like, O and O, 3.5. However, because this lone pair, they do not cancel out because there's an unequal thing. Yeah. So for H2O, this should be this should be polar. Okay, next up is the boiling point. Boiling point is the substances that have strong intermolecular forces tend to have high boiling points. So strong intermolecular have higher boiling points. So evaporation and vapor pressure. Substances often evaporate more due to weak attractions between particles. Surface tension. Surface tension is an inward force that tends to minimize the surface area of a liquid. It tends to cause the liquid to behave as it were covered with thick skin. Increased surface tension is caused by particles being more attracted to one another. So minimize surface area of a liquid. Oh, by the way, intermolecular is just the attraction between separate particles. So, yeah. Intra is within the ionic. So, yeah. Oh, and intra are stronger than that one. Alright. You also need to know that where is it? You basically only need to know that melting point, a boiling point, and surface tension, and evaporation rate goes down as the IMF is higher. So, yeah. So the types of IMFs. Dispersion, weakest, hydrogen, strongest, dipolar, dipole, or dip induced, dip, which doesn't really, I don't think it's gonna be on the final. So this is between non-polar. This is non-polar and polar. This is polars. And this is hydrogen with O, N, or F. Think of it like OnlyFans. Like, OnlyFans. I bet. Oh, no. So, that's basically it. I don't know what else to say.